4 lines. Okay. IQ scores are normally distributed. With a mean score of 100 and a standard deviation of 15 points. I want you to sketch the normal curve and give the 7 key values. Because it's normally distributed, we know it has that nice bell shape. There are 7 key values on that number line. Okay, this one doesn't have to be big. But I do want the 7 values here. Where do we start? 100 in the middle, there's the mean. How do I know how to get each one of these divisions? Add 15 each time. So this first one's going to be 115. Next one, 130. Next one, 145. How do we get the ones below? Subtract 15. This is not difficult stuff. 85, 70. Anybody ever take an IQ test? I don't know when they do this. Okay, once you've got that curve and we know some probability stuff or areas, can you tell me the probability of randomly selecting a single person? I'm going to pick a person out of the crowd. And what's the probability that their IQ score is between 85 and 115?
What's like the average?
Average is 100. That's the mean. Your average IQ score is 100. I'm going to say all of you are probably above average.
Yeah, okay.
I'm going to say this whole class is probably between 100 and 130. I don't know if we're getting anybody up here. I don't know. It's my guess. And what's this probability that I pick someone that's between 85 and 115? Because those are exactly one away. Those two chunks add up to. You can put point. The book does all decimals. Because that's 68% of decimal. The probability that that person you pick is between 55 and 85 IQ score. What do I have to do to get that one? Guys in the back paying attention? Yeah. 55 to 85? What are we adding up there?
Wait, I'm confused.
It's these bottom two chunks here. So it's the, which two are they? It's the 13.5 and the 2.35? So 0.0235 plus 0.135. I'm adding up the two pieces. See it?
Wait, how? 1.85?
You need to number them. 1, 2, 3. I'm adding up these 2 and 3 chunks. If you look back, 1, 2, and 3. It's these two added together. So that's where my 55 is, and that's where my 85 is. Yes? No? No? Do you see where the 55 and 85 are?
Yeah.
So that's my question.
Yeah.
So I want to know how much area right here for these two pieces.
That's
I've told you up here what the areas are by the percentages.
But aren't they going to be like different?
No, not if it's normal. All normal data calls fits this curve.
But
That's what's
because
big.
like when the mean changes, that's when that changes too?
Nope. Nope. Not at all. It all fits the normal curve. You'll see when we do another one. So if I add these two together, what does this come out? 1585. And let's do one more. The probability the person you pick has an IQ score between, oh, let's go 140, 130, above and above and up. 130 and up. What are you going to do there? Smart person. What's the probability we pick out a really smart person from the crowd? Randomly. Yep, 0.0235 plus 0.0015, take them both into decimals. And that gives me a 0 on the end, a 4, a 3 and a 2.
Wait, what?
Do they add correctly?
0.025.
5 and 5 is 0. Oh, 5, I need a 5. I'll carry my 1. Now am I right?
There's no 3 there.
Oh.
Where'd you get the 3?
3 plus 1.
0, 3 and 1, plus 1, and then it's 2 and 0. How'd I do?
There you go.
Oh! Can't add horizontally very well.
Everybody has flaws. No. I don't think she really cares. Like, she does, but she doesn't. Yeah. Are we almost
Nope.
done?
No, we're not almost done.
Why not?
I'll try.
Estimate the mean and standard deviation of this normally distributed data. If this is what I tell you.
I don't like this little box.
This is an estimate now. 3.5 is what? The mean. That one's pretty easy. So the mean is 3.5. How are we going to estimate what the standard deviation is? What assumption are we going to have to make here?
That's 1 away.
That this 4.1 is 1 away? I would assume that that's 3 away, because it's right where it's starting to tail off. So that is the assumption we're going to make, that that's what we're going to assume, that this is the third one out. So I need to know how much that jump is, because that's the standard deviation. How are we going to do that? Andrew?
4.1, check 3.5 and divide by 3.
There you go. You need this distance from 3.5 to 4.1. And we want to divide that into 3 equal jumps. I don't think I'm going to be able to do that in my head. Point what? 2. So it's about 0.2. That's a good estimate. So that was the assumption we had to make, because it was all way out by where it started to tail off, that was 3 away. Okay. We're going to get a little start on the next section. So start a new section and note. No, we're not. No, we'll call them 2 points. So we won't remember that we did this all one day. Whole new section. And we only got like 5 minutes to get started here. 5-2. So what we want to be able to do is get probabilities for things that aren't exactly on 1, 2, and 3 standard deviations away. Maybe we're closer in here. So,
We don't have homework. Here, let's do it.
that's right. We don't have homework. We're complaining.
We don't have homework.
Well, may I use that? No.
You're missing out on important information.
No, can you?
May I?
Yes.
I don't know if I have grammar or not.
I'm not. Standard score is called a z-score.
Why?
I don't know why they use z. Kind of like it though. We hardly ever use z. A z-score represents the number of standard deviations away from the mean. So, in our first example, we're going to look at some utility bills that are normally distributed. The average utility bill is $70 a month, and the standard deviation is $8. I first want to sketch the graph. Oh, didn't give you the formula, for God's sake. I got ahead of myself. Do you have room to stick a formula back up here? All right. I jumped over it. I was trying to hurry up and get it in. This is all we're doing here. So the z-score, to figure out a z-score, let's do this first. I'll come back to that. Kind of build it in. Sorry. Because I'm trying to rush and not rush. And so $70 is the mean. One standard deviation above would be $78. I'm just adding the 8 on. The next one would be 86, and the last one 94. Good morning. Sure. Bye. Andrew, stop in and see Mrs. Hudvin when you get a chance. Okay. Subtracting $8 brings us down to 62, 54, and 46. Okay, we're going to be finding z-scores. Find the z-score if a bill was $86. I'm going to start easy here. So I write it as the z-score for $86. And the z-score is how many standard deviations away from the mean you are. Well, how far away is 86 from the mean? Exactly 2. So its z-score would be 2. What if it was $46? What would the z-score for $46 be? Is it 3? Close. -3, because you got the negative should indicate that it's below. What if I gave you a z-score of, a bill of $75? You can see it would fall in here. So it's less than 1, but how are we, this is where the formula is coming in. How do we figure out how many standard deviations above the mean that is? By using the formula I didn't give you. What are you going to have to do? Do you think? Subtract something. Take your x value